Good evening, everyone. Nice to see you. I hope everyone has enjoyed that beautiful meatball over there. We are from Summer Experience at EnVision 2018, and I'm honored for this opportunity to explain our design exhibit back there. So I think it's appropriate for us to introduce who we are first. We are a team of 10 from multidisciplinary background. We have different majors and interest group. For instance, I myself is a computer science major, and there's mechanical engineering majors and visual art majors. We're all mix of a huge team. And in the first week of our internship, we were a little bit clueless what we were going to do, so we had to get our objectives straight. So this was the mission objective that we got from our job description. It says, student teams will work from concept to prototype on an interactive, multi-sensory installment that combines science, technology, and human-centered design. I mean, it's a great objective, but we had no idea after reading that sentence, so we had to reiterate and think about what we're actually doing. And this was the purpose that our client, Birch Aquarium, had, which was to connect engineering and visual art students on campus with Birch Aquarium and offer students an opportunity to foster their creativity and, of course, to provide Birch with a new experience with guests. So that was the objective for Birch, our client. And the topic of this exhibit is wave. It's pretty broad. So why wave? Waves are everywhere, and wave is related to Scripps research as well. And also, it's a rich subject, as it says, for science learning at the aquarium. So the wave was the main topic of our exhibit. However, as I said, wave is a broad topic. It can be ocean wave, or mathematical wave, or sound wave, or any kind of wave. So we wrote down everything that we know about wave to narrow down what we're going to approach. And I like this approach because even though it was a little bit ambiguous, it's a quote from our director, Nan Renner. She said, exploratory design forces us to embrace ambiguity, even though it is uncomfortable because finding our own way is a path to innovation. And also, I've learned that this is actually professional exhibit development. It doesn't come from specific requirements, but it comes from concept, and we develop upon it. So it was a new process to me, but I liked it. And on the second week, we got to know more about the Birch Aquarium and this stuff. And it was done with Design Jam. It's a little 3 days schedule that we had, and we interacted with the Birch staff and the objective that we had. We walked around the aquarium and thought about the soundscape, where would the exhibit fit, and what we're aiming for. And Dr. Dale Stokes, he was our science lead, who helped a lot about the science aspect of this exhibit so it can be accurate and represent the correct scientific idea behind it. And not only that, we had an opportunity to do user testing with actual Birch visitors. As you can see, that kid loved what we had from a rapid prototyping design, but it gave us a lot of insight on what we should aim for, and the feedback that we got helped us to build what we have right now. And to get some inspiration, we went to San Francisco to the Exploratorium. Exploratorium is one of the best interactive museum in the world, and we were able to talk to exhibit director Eric Thorson, and he gave us a lot of practical tips on how the building of exhibit becomes. Also, one of the important things that he told us is that the first 15 seconds of the exhibit is where people would interact most, like a lot of practical stuff like that. It was amazing. And not only that, we looked at the paper published by Exploratorium, so not just from our hunches or wild guesses. And I'll leave it to Chris for design requirements.
Alright. At this point in our project, our whole team was itching to try to find out how to make this project. But the problem was we didn't even know what we were making yet. And the issue is that this was probably the most intimidating part for me. The fact that how different this was from a classroom environment. For example, in class, we would be given an assignment, which is to make a robot. And this robot would have a specific task, it would have a time constraint, a size constraint, and even a material constraint. While in this case, our project only had one constraint, that our exhibit has to be about weights. In a way, this was intimidating, but at the same time, it was very freeing because we could do literally anything we wanted to do. But how do we choose from a pool of infinite possibilities? Luckily for us, that wasn't all we had to go off of. This was actually intentional, allowing us to widen our perspective and deepen our understanding of this subject. This kind of exploratory design process was a new process, something I've never done before. And instead of us being constrained to one singular path, it rather nudged and guided us towards a specific goal. The 4 guidelines that guided us through this process were ingrained in our heads ever since we first met up with Virtual Learning. The first being Conceptual Beauty. It means that the exhibit has to provide a foundational understanding of a scientific concept. Next is Aesthetic Delight, which means our exhibit has to be visually striking and audibly pleasing to our senses. Social interaction means that our exhibit has to foster discussion between our guests so that they can critically think about the scientific concept at hand. And lastly, physical exploration means that they have to be able to probe their curiosity through their interactions with our exhibit. And these are all awesome guidelines, but now that it was time for us to start designing, we needed to make our own design requirements. The freedom of exploratory design really allowed us to make requirements tailor-made to Virtual Aquarium's needs. Most notable of those being that we had to integrate research from the Scripps Institution of Oceanography because it is part of Virtu's mission to connect the general public to the research being done at Scripps. Next, it had to be safe because a big majority of our guests are actually children, and they can't be getting hurt while they're trying to do science. And lastly, it has to be inclusive of all ages. A good piece of advice we learned from the Exploratorium was that if the adults are engaged in learning, the kids are going to naturally follow. And to be honest, that lack of constraints was really uncomfortable at first, but we're about to see how embracing the ambiguity really led us to innovation. And now that we knew what we were trying to accomplish, we could finally focus on the how. And we would do this through rapid ideation. The keyword here is rapid, which means that we would try to get as many ideas out as we can, as quick as we can, so that we can pump out all the good and bad, and then have a good pool of ideas to choose from. But at first, it really wasn't rapid at all. In fact, it took us, I think, a whole 2 days to come up with a grand total of 4 ideas. And it's important to note that the first 4 ideas never even made it past that first wave of down selection. And at this point, our project manager, Gabi, stepped in, and he issued us a challenge. He told us, all right guys, in the next 2 hours, you have to make 15 ideas. And in my head, I'm like, dude, there's no way. This is an impossible task. Well, in the end, we came up with 27. 27 ideas, which 20 of them were prototyped with whatever we can find in the lab, which means it would be made of styrofoam, balsa wood, hot glue, and tape. And out of those 20, 7 were chosen based off of their potential to fulfill our design requirements. These 7 low-fidelity prototypes were just enough to show proof of concept. Some of those concepts included waves transferred through mediums, resonance, and sound interference. At this point, Nan Reiner from Virtual Aquarium came by, and she provided us feedback. And we took those feedbacks and further down selected to 3 final prototypes. Those prototypes would go forward to a mid-fidelity level, which means that we would actually start building. Hot glue and tape turned into nuts and bolts, a balsa wood turned into plywood, and we even used laser-cut acrylic. When planning out these builds, we realized each build had 3 major components, and to efficiently build these, our team naturally split up into those 3 teams. Hardware would be in charge of all of the physical components of those exhibits. Software would be in charge of the electrical and digital systems, while user experience would be in charge of game flow and user interaction. While building these 3 prototypes, this is when we first encountered the real challenges with teamwork. First of which, and foremost, being communication. We learned that communication was a lot more than just talking and listening, but in fact, it was the responsibility of both parties to be able to come together and make sure that what was said is equal to what was heard. We also had to get used to constant reiteration. The fact that failure was in fact a norm. We would fail so many times before we succeeded even once. And we just had to work through that. Because the faster we succeeded, or the faster we failed, the faster we would succeed. And after a rigorous 2 weeks of building, a little bit of screaming at each other, we finally brought the prototypes to Virtual to hear what they thought. The first of those prototypes is a kinetic wave sculpture. This demonstrates wave propagation through mediums and also interference. Visitors would come to either side of the sculpture, and they would wiggle the little lever to create a wave. It would propagate through the spine and interfere right in the middle. It's pretty cool, right? Let's check out this next one. This is a sonar obstacle course. This one demonstrates how animals and humans use reflecting sound waves to actually navigate the ocean. Visitors would be able to place their obstacles into the maze and cover it up, and then navigate that obstacle course using only the sound of sonar. Yeah, it's really cool stuff. Well, wait until you see the one that was ultimately chosen. This one. This is a wave matching game. This one demonstrates how the frequency of a wave actually changes how we perceive it. The way this one works is that a reference tone would play. A user would come in, and they would actually manipulate the wave in order to try to match that reference tone that was played. And now that we finally had the final concept locked down, here's Hazel to explain what we did next.
So Aquarium gave us some really important feedback after we presented these 3 prototypes, and that they wanted us to integrate the scripts research into our exhibit better. They suggested to us to include natural marine life sounds. And this was a really important piece of feedback because the purpose of the aquarium is to communicate the research being done at Scripps. And so, as you remember, this is our original prototype. That is a sound matching game. But this didn't really capture any of this research being done at Scripps because it was only about a single wave property, frequency. And so that meant we went back to the drawing board. How might we integrate natural sounds into our exhibit? You know, natural sounds or frequency tones are inherently very different, and trying to compare one and use one to represent the other would lead to a loss of conceptual beauty, and visitors wouldn't really be able to understand the signs that we were trying to communicate with our exhibit. And so after a lot of brainstorming, we came up with a new idea. This is our exhibit's main idea. Noise and sound pollution is a major problem that marine life currently face. And this exhibit helps visitors understand what it's like to be an animal in the marine life and trying to make and understand meaning from their world. So imagine trying to be in an environment where you're trying to have a conversation with another person. You know, generally it's pretty easy if the environment is pretty quiet, but once you add more people that are also having their own conversations and maybe there's construction going on in the background, it becomes a lot harder to understand what they're saying, and you need to increase your focus and attention in order to make understanding of what they're saying. And so this is what our exhibit is trying to do. So how exactly does it work? So this is a pictorial representation of our exhibit face. And it plays the marine sound in the background, the soundscape of all the frequencies, of all the animals, and all the ship sounds that are happening at the same time. And those 2 sliders in this slide are how the frequencies determine what sounds are being played at a specific time. So there's no headphones needed for this exhibit, so we're coming for a lot of different people, so more people than just one are able to use our exhibit at a time. And so this top slider at the very top, for example, if it's all the way to the right, and when the bottom slider is all the way to the left, that means everything is playing. So all of the animals that are available to be played, and all the ship sounds, and all the engine sounds are all playing at once. And so visitors will use the sliders as a way to determine what frequency of the range that they want to hear. And so the way you go about to use this is to choose a specific animal in the selection of 5, for example, the California mantis shrimp. And the sounds that are playing are reflected by the area that the sliders are in. So this entire red section is all the frequency range and all the sounds that are playing that are within that range. And if you're not in the correct range, that means all the animals that communicate within that range, along with the extra noise pollution sounds, are playing at the same time. And the way that guests interact with this exhibit is by sliding the sliders back and forth. So for example, if you move the bottom slider to the right, you have to hear a change in what's heard. So for example, before, while everything was playing at once, you move the bottom slider a little bit to the right, maybe one animal disappears and you're only hearing 4 animals and all the ship sounds. And so as you're focusing in on specific ranges, only animals that communicate in those ranges are being heard. So as you're moving the sliders back and forth to the left and right, you will eventually only focus in on the California mantis shrimp. And that means you have filtered out all the other animals and all the extra sounds that are that could have been playing, and you have finally understood what it's like to be a California mantis shrimp in the seascape. And so once you get it right, the green light will turn on. And so once we figured out and finalized our concept, we had to go into building the actual exhibit that you'll be seeing today. And so this is our 3D modeling render. This is what the software that we use to design the specific parts for each of our exhibit. And we also use it to visualize how each of the individual parts will be put together and to see if it would even work in the first place. And once we finalized this rendering, we then were able to actually start building it physically in the real world. This is the main mechanism for our exhibit interactivity. This is called the scissor mechanism, and it allows for smooth and equidistant movement of the sine waveform within our exhibit. And as you can see, there are a lot of little parts that all needed to be put together with specific hardware components, and that meant that it took a lot of time. But what also took a lot of time was that we had to do a lot of engineering and reiteration design work to make sure that what we were putting out there was an experience that visitors would actually enjoy. So as you can see, there are a lot of little parts, and each one of these is a layer of a scissor mechanism just to solve a different engineering problem that we were faced with after trying to solve one. And so we also did electrical components in our exhibit. Here we are soldering and creating the circuitry for the electrical components of our exhibit. And so we went from a prototyping stage with breadboards and just being able to physically put in wires into a specific place. But then after a lot of reiteration and going back and forth, a lot of trial and error, we've created an actual electric circuit board that will actually house the exhibit and to create an experience for the visitors who play with our exhibit. And so this is what our final exhibit looks like. It's not just a visual experience, but it's also an auditory experience as well. You can see the waveform, which is a pretty striking image, and the shape of that waveform is actually represented by the kind of frequency that you're hearing. So the one at the top, you can see is more compressed. That represents a higher frequency, and that's what it represents. And you can hear the soundscape change as you dynamically move the sliders back and forth. So as you're seeing the waveform change, it correlates to what you are hearing, and that is shown by the waveform itself. So throughout these 10 weeks, we all learned a lot of different things. We all came in with different skill sets, but we all came out with a lot by learning a lot. Either it was through a technical workshop, through like a public speaking workshop with Rady, or even it was just us applying the skills that we knew and experienced of this internship. We learned how to apply the skills we knew in a real life environment. We learned technical skills like soldering and circuit design. And we learned soft skills as well. As for example, we had to learn how to accommodate for real life constraints like time and money. And there's also something else that we all really learned and really got to experience this summer. And it was that this was the traditional view that we came in with. It was this classroom experience where you already have the product design requirements set in the form of an assignment. And you know exactly what you need to do in order to get a certain amount of grade, and you have to finish it by the certain due date, and then you're done. But that's not exactly how the real world works. In the real world, you have a lot of different steps before the product design requirements are set. And you need to understand what the client wants, what their needs is, what their vision for the project is. And then after you understand all of that, you have to then distill it down into what you can do to generate a lot of different concepts. And by a lot of different concepts, we really mean a lot. Because you want to make sure that the one concept you go forward with is the one that's actually addressing everything that your client wants and needs. And then, only then, can you then have the product design requirements set and then be ready to build. And another thing that we really learned from this experience is that product lives beyond the due date. You know, a traditional classroom assignment, you finish it, you turn it in, and you can wash your hands of it, and you're free. But in this case, we were building an exhibit that we want visitors to the Birch Aquarium to really enjoy for years to come. And that really meant that we put a lot more effort, and we really wanted to make sure that this project succeeded. So I'd like to thank you all for coming tonight, but we'd also like to thank specific people, namely Jesse DeWald, Mark Liu, and Gabi Shafson, for being not only our mentors throughout this entire project, but for really pushing us into becoming better designers and engineers. And we'd also really like to thank Nan Renner and the rest of the Birch Aquarium for not only trusting us with this exhibit, but also providing us this experience and to support us through this entire experience as well. And we look forward to any and all future summer experience at EnVision projects to come.
That was super impressive. Maybe all of you could stand up because it was not just three of you that did this project. And get a round of applause again from the audience. Good evening, everybody. Thank you all so much for being here to celebrate this experience with us. My name is Jesse DeWald, and I'm the staff director of the EnVision Arts and Engineering Maker Studio, and also the lead of the summer experience in EnVision. I am the last man standing up here before all of you are let loose to experience this amazing exhibit that all the students have put together. So I will keep my remarks super short, maybe 90 seconds or so. What I really want to do is stand up here and thank every one of you individually for all the support you provided us as we achieve these successes. And I think it's probably most important to put a bow on what Dean Pisano started saying, and that we couldn't have done this without you. Certainly our science advisors at Scripps Institution of Oceanography, the Birch Aquarium staff, the leadership in the Jacobs School of Engineering, our amazing alumni, thank you so much for all of your time and effort that you've given us. And of course, our donor support from the Powell Foundation, who really believed in this program before we even got started. And I hope that you enjoy the fruits of that belief today. As a parting note, I'll just say that I believe the impact of this program is far greater than the experiences that our students have had. And the experiences that I've had as well. It's really the strength of what we've done here is develop these deep interdisciplinary relationships across our vast campus. And it is these types of collaborations that are going to continue to change the world here in the work that we do in UC San Diego. So I feel very privileged to be a part of this and part of that, and I hope all of you feel that you're a part of it as well. Thank you so much for being here tonight. And with that, I'm actually going to hand this over to Dr. Nan Renner, and we are going to usher you into to see and use the exhibit. So thank you all so much.